So up on screen, we're about to walk through a typical architecture for the 5G transport network topology. It's important to note before we start that there will always be variations on this topology. It depends on the service provider and it depends on the architecture of the network overall. But we start with the core network, and as you can see within our core network, it's fairly typical to see a mesh design. So we've got full interconnectivity, but you could just as easily see a spine and leaf type deployment in our core network. In terms of data throughput, at the moment, we're around about 400 gigabits per second. It won't be long before we can achieve 800 gigabits per second on a wide scale, and beyond that, we'll be up to 1.6 terabits per second. As we move towards the cell site, we hit the kind of metro and aggregation side of the network. And here we've got a spine and leaf deployment, but again, it could be a ring deployment, for example. So we've got n times 100 gigabits per second connections in the kind of metro part of the network. And this is where we typically encounter edge data centers, maybe with some MEC deployment. We might see regional data centers supported here as well. As we get closer to the cell site, we're adopting a ring topology. And with that ring topology, we've got data throughput at around about 50 gigabits per second. But again, there could be variations. We might not use ring topologies. We could use star topologies as we get towards the cell site. We could use chain topologies. We've also got the endpoints there as well. The endpoints are essentially the cell sites in the context of our discussion. So that's the kind of a typical end-to-end deployment that you might encounter, but this is purely fiber. And remember, fiber, particularly as we get towards the access network, will be augmented by other technologies. We'll see microwave, we'll see integrated access and backhaul, and we'll also see the use of non-terrestrial networks to support this infrastructure. Now, just to put this into greater context, we've got a deployment example. So you can see from the next diagram, how would you position something like a disaggregated G node B? So a disaggregated G node B, maybe with the kind of open RAN methodology, you would see a remote radio unit, a distributed unit, and a centralized unit. So using our kind of topology for fiber, where would we see those components deployed? Well, you can see that we've got our backhaul up to the 5G core network, and that might be a ring or a mesh, or it could even be a spine and leaf topology. And I guess servicing the end of the backhaul there is the centralized unit, and we've just got the controller element here. There could be a user element as well. Connecting us up to the, as you can see, the distributed unit, we've got a mid-haul connectivity, and that again is our ring architecture, our ring topology. And then with the distributed unit connecting us to the remote radio units, we've just got a star topology. We could have a ring topology. We could have a chain topology. But again, this just gives you an idea of the kind of topology overall of the fiber infrastructure. Notwithstanding, we do have those other technologies, microwave, NTN, and integrated access and backhaul.